Hi, welcome back to the channel. In our last lesson, we saw resistance and resistivity. In this lesson, we will see resistance in series. I will explain the unique characteristics of resistance in series and use two work examples to explain how to work with resistance in series. Thank you, and let's get into class. Basically, there are two ways you can connect your resistance. You are either connecting the resistance in series or you are connecting it in parallel. But today our focus is on connecting our resistance in series. We're looking at the series circuit. Now there are two unique characteristics about your resistance when they are connected in series. Number one is the voltage. Now what's actually a series circuit? Let's see a series circuit. Now if I have my resistance this way, I have two resistance or more. Let's even have three resistance. If I have three resistance and I connect them end to end, that's the unique characteristics of resistance in series. They are connected end to end. One end of one resistance will be connected to the front of the other resistance. Now, so that if this is R1, I've connected the end of R1 to the beginning of R2. The end of R2 connected to the beginning of R3. Now, when resistors are connected this way, and you now connect them to a voltage source, we say they are connected in series. Now, the first unique characteristics about them is the voltage across R1, let's call that V1, plus the voltage across R2, let's call that V2, plus the voltage across R3, V3, will be equal to the total voltage of the circuit. Now there's a voltage powered by probably a battery source or an AC source, but for now we're actually dealing with a DC source. So this DC source is going to supply current, and there's going to be a voltage across each of these resistors, so that my VT across all the resistor will be the same thing as the sum total of V1 plus V2 plus V3. Now, another unique thing is the current that flows from VT will actually be delivered through V1, V2, and V3. That is, the same current that flows through V1 will also flow through V2, and I also will flow through V3. Now, so if I is flowing through all the circuits, if I have I, this is a circuit once again. Let me quickly draw the circuit. Now we've established that I is going to be a unique current flowing through this circuit, and I have I flowing through this circuit. Then I'll have V1 here. The voltage across this will be V2, and the voltage drop across R3 also will be what? Will be V3. Now, so that my V here, which is from the battery, is V now will be equals to V1 plus V2 plus V3. Now with that, remember that our voltage V is equals to current I times resistance R. So if V is equals to IR, now for V, that means it's the same thing as I1 here is I into R1 plus I again will be into R2 plus I again into what? R3. Now, what we're saying is my V1 here is equal to the current I times R1. My V2 is the same thing as the current I, because the same current flows through them, times R2. And my V3 is the same thing as I into current R3. Now, so that your voltage V will be the same thing as I is unique to the three resistance. Then I can bring I out and have R1 plus R2 plus R3. So that now in place of R1 plus R2, R3, we can now use that as our R total. So that my V now is uniquely the same thing as I times RT. Now that brings us to the third unique characteristics about resistors when they are connected in series. The sum of the total resistance of the circuit is the same thing as the sum of the individual resistance. Now we have established three unique characteristics. We have established that the voltages the voltage drop across each of the resistors is, we've established that the sum of the voltage drop is the same as the sum of the individual voltages. The resistance, the total resistance, is also the resistance, is also the sum of the individual resistance, and we have also established that the same current I flows through the circuit. That said, let's see a practical example. Our question says, for the circuit shown below, determine the battery voltage, the total resistance of the circuit, and C, the value of resistors R1, R2, and R3. Now, one unique thing I want you to note about this is that our voltage V, remember we said the voltage V for a series circuit is the same thing as V1 plus V2 plus V3. So the first question A will come from V. Now, we've been given that our V1 is the same thing as 5 volts. Our V2 is the same thing as 2 volts. And our V3 is the same thing as 6 volts. So that V is equals to 5 plus 2 plus 6. That's the same thing as 13 volts. So the total voltage is 13 volts. The second part of the question says we should determine the total resistance of the circuit. Now, if the total volt is 13 volts and a unique current I is 4 amps, from the diagram we can see that we have 4 amps across it. Now, I know that my V total is the same thing as I times R total. So that R total will be the same thing as V over I. Now, here we just perform a simple change of formula. In case you miss our lesson on change of subject formula, you can check the link in the link here. We'll place a link up here for you to access that. And also we'll also leave a link in the description below. Now, this is the same thing as 13 over 4. Now, 13 over 4 is the same thing as 3 whole number 1 over 4. That's equals to 3.25. The question says that we should calculate the value of resistors R1, R2, and R3. Now, that's easy because we already have the individual potential differences. Now, for R1 will be the same thing as V1 over I, like I did explain initially. That will come from my V1 is the same thing as 5. That's 5 over 4. That's equals to 1.25. My R2 will come from V2 over I. That will be the same thing as 2 over 4, which is equal to 0.5 ohms. Resistors are measured in ohms. Then my R3 will come from V3 over I. V3 over I is the same thing as 6. V3 is 6 over 4. Now that's 2 here is 2. 2 in 6 is 3. That's the same thing as 1.5 ohms. Now, good to mention that resistors are measured in ohms, currents are measured in amperes, and voltage or potential difference is measured in volts. Now, let's see the last question. Now, let's see the last question. Our question says, for the circuit shown below, determine the PD across resistor R3. Oh, let me label it. Sorry, I didn't label it initially. This is R1, R2, and here is R3. Now, the PD across R3 is the same thing as V3. Let's take that first. Now, if you look at it carefully, the total voltage is 25 volts. Now, the PD across R1 will be V1. That means 25 volts, which is the total voltage, is the same thing as V1 plus V2 plus V3. Now, 25 volts will be the same thing as 10, that's V1, plus 4 in place of V2 and plus V3. So that's 25 will be the same thing as 14 plus V3. So that 25 minus 14 is equals to V3. Then V3 will be the same thing as 11. It says if the total resistance of the circuit is 100 ohms, determine the current through resistor R1. Now, the unique thing about the total resistance, we've been given the total resistance RT to be equals to 100 ohms. Now, if the total resistance is 100 ohms, the first question is, what is I? I is going to be the same thing as V over RT. which is equal to 25. That's the total voltage over the total resistance, 25 over 100. That's equal to 1 over 4, which is equal to 0.25 amperes. Now, the voltage, though we are asked to find the current across R1, but the unique thing is the same current across R1 flows through R2, flows through R3. That is the I in the circuit, which is 0.25 amperes. Now, the last part of the question says, find also the value of resistor R2. Now, to find the value of resistor R2, we've been given V2 to be 4 volts, so that R2 will be equals to V2 over I. That's equals to 4 volts, 4 over 0.25. 4 over 0.25 from my calculator should be the same thing as 16. That's 16 ohms. That's 16 ohms. Now, I hope with this you can attempt questions relating to solving resistance in series. In case you've not subscribed to our channel, please do not hesitate to hit the subscribe button. That way, you'll be telling YouTube you love what we're doing and you'll encourage us to do more. Thank you and see you in another class.